Hi everyone, so we're moving on to our last unit here, talking about galaxies, and so we are going to start with our galaxy, the Milky Way Galaxy. So some questions: how many stars does the Milky Galaxy contain? Where is our solar system located? And is our sun moving through the Milky Way Galaxy? And how fast? So we're going to discover a few things here, looking at galaxy made of billions of stars, gas, and dust, all bound by a gravitational attraction. Properties of our Milky Way Galaxy, Earth's location. There are a huge black hole that is actually at the center of our galaxy, and some observations here. So if we take a look at our Milky Way Galaxy, we can see our disk here that surrounds the center. Our sun is over here in part of this disk. We can see our bulge here. And then what we call the halo is just these kind of random stars that really don't fall into our disk here. So taking a look, we also see that we're seeing spiral arms in our galaxy, and our latest research shows that it also has a bar at the center that you can see here. So something to note here is that we have those spiral arms that come around and that bar in the center. So how are we looking at the galaxy from ours? So when we take a look at some different radio waves and gas clouds, we can see slightly different. So we can see our sun here, and of course our solar system is rotating around our sun, but our sun is more out and not towards the center of our galaxy. So though the sun is the center of our solar system, it's not the center of our galaxy. So if we take a look, we can see our map on the left, looking at different radio telescopes and the different radio distributions. So because of those different spiral arms, we're going to see a different distribution of our hydrogen gas that we find in the Milky Way. So if we take a look, we can see all these different distributions. So here we are, and here is the actual center of our galaxy, and you can see how different these look on the sides there. So how many stars are in our galaxy? Our diameter is 100,000 light years of only visible stuff. So our stars, planets, all those types of things is 100,000 light years. So to get from one side to another for light to travel, it's going to take 100,000 years. But when we talk about dark matter, we have a much larger area in the Milky Way Galaxy. It's also 2,000 light years thick where we are. So to get light through from our solar system, it takes about 2,000 years. We're going to see about 200 billion stars in our galaxy. And the sun is actually 26,000 light years from the galactic center of our galaxy. So we're going to see our galactic center. It's going to take the sun, light to travel, 26,000 years for light to travel from the sun to the center of our galaxy. What kinds of stars are we going to see there? So at the nuclear bulge, again, 20,000 light years in diameter. Our disk is going to contain gas, dust, and a population of 1 stars. So young and metal-rich stars. And the halo that's found kind of around our actual thick composition of stars here is going to be composed of population 2 stars, which are kind of old metal poor stars that we see. So what kinds of stars? In our disk, we're going to see population 1 stars that are young and metal-rich, and in our halo, we're going to see population 2 stars, which are older stars and metal poor. So our view towards that galactic center, more than 1 million stars in the disk of our galaxy fill this view from when we look towards the nuclear center, which is actually called Sagittarius. So we have millions of stars that are in between where we are and where their galactic center is. So if we look towards our galaxy center, what we can actually see, we're going to be looking for Sagittarius here for visible light. And again, another view looking towards our center, towards that Sagittarius in infrared light. So a different type of light that we can see here in that relation. So if we zoom in on that galactic center, we can see there's a very, very high density at this center. So here, moving closer and closer to our galactic center, we can see these red dots of very, very high density at the center of our galaxy. So our galactic nucleus in radio waves, so Sagittarius A is our visible galaxy center, and it's very, very bright radio waves. So we can see that here with those very, very bright radio waves. But again, it's going to be surrounded in what we call SNR, or supernova remnant. So this star went through a life cycle, or it was created in this cloud, our supernova remnants, and is going to be very, very bright at the center of our galaxy. Because we know that stars are recycled, so all the stuff that was released during a supernova explosion is going to create that new star. So if we take another look, we can see that the stars are actually orbiting a massive object that cannot be seen. So what objects cannot be seen? We're going to see a black hole here. So our black hole is a 4 million solar mass. So again, if we compare it to the stars, some of the stars that we've looked at, 4 million is a massive, massive number, has really huge mass, which means we're going to see an immense amount of gravity. So if we take a look here, we can see our timeline and see kind of this different orbit style, which is a little bit confusing to see here, but we can see how these stars have been moving and they're projected. So the line that I just drew is for Sagittarius 1, and we can kind of see that orbit moving around this object that we cannot see. So our black hole area at the center of our galaxy might kind of look something like this if we were to look at it using this infrared type look here. So this is something that we might see using that Hubble Space Telescope, which is something that's really helping. So actually we can see here that we're using radio images, which is how we might be able to predict what that might look like. So orbits are in different parts of our galaxy. Stars are going to look different. It's not going to be that very perfect orbit that we see. So we can kind of see how this orbit is a little bit wavy here, because not everything is going to be that perfect circle that we're used to seeing. So when our galaxy rotates at the center is going to rotate faster than our outer parts. There's a heavier gravity on those inner stars, so that's why it's going to be pushed forward. This is going to be called Kepler's third law. It's something that we also see with our own solar system. Our planets that are closer to the solar system have a faster orbit than the planets that are further away. And the same thing is going to happen with our stars. So this one is not what's going to happen. We're not going to see that these stars are going to be perfectly lined up moving together. Instead, these stars that are closer are going to move probably quicker and move faster than these stars that are further away. So if we take a look at our galaxy's rotation curve, It shows some dark matter beyond the visible edge of our galaxy. So if you look, there's no material beyond the visible edge, but our orbit speeds at large distances are going to decline. And this is something that we can't really observe here. So this is the actual curve. If there was nothing, we would expect to see this decrease. But since we know there's something out there, something that we call dark matter, we see that this line is going to continue to go, which is a little bit interesting to think about. Okay, so how much dark matter does our galaxy have? So our stars and other objects that give off radiation only account for 10% of the galaxy's total mass. So there's another 90% of our galaxy that we can't even see. So in ideas, whenever we think of things that are something that we can't see, like black holes, black dwarfs, it's something dark per se. So we call this stuff that we can't see, does not give off any radiation, dark matter. So dark matter forms a sphere around our galaxy at least 12 times farther from the center than we are. So that's a really great distance away. And we don't know what dark matter is, but we know that it has gravity because we see those effects in orbits and things like that. So some of the questions: how many stars does the Milky Way Galaxy contain? It contains about 200 billion stars. Where is our solar system in location to our galaxy? It's on what we call the Orion arm, and it's about 26 light years away from the center of our galaxy. So again, this the light from our sun to reach the center of our galaxy is going to take 26,000 years to reach there. And then, is our sun moving through the Milky Way Galaxy? If so, how fast? So the sun orbits the Milky Way Galaxy at a speed of 828,000 kilometers per hour. So it's a really, really fast time. So we know that. So we are moving, ironically, very fast, but we're not feeling those effects, obviously, with our own, because as the sun orbits our Milky Way Galaxy, we are doing our normal orbit, orbiting the sun, which is interesting to think about. Okay, so that's it for the Milky Way Galaxy. Next time we are going to talk about other different types of galaxies and take a look at all those different types. Remember, if you have any questions, make sure you ask.